Hi guys, this is Mrs. Lyons. Today we're going to talk about covalent bonding, and we're going to talk about drawing pictures of things that are covalently bonded. Before we start, I want to remind you that when we look at elements on the periodic table, we can tell how many valence electrons each element has. Okay, so we know that everything in group 1 has 1 valence electron. Everything in group 2 has 2 valence electrons. Everything in group 13 has 3, 14 has 4, 15 has 5, 16 has 6, 17 has 7, 18 has 8. Okay, so that means that we can draw Lewis dot structures. Say, for example, we wanted to draw a Lewis dot structure of carbon. We would draw it with 4 valence electrons, 1 on each side. So 1, 2, 3, 4. Okay. If we wanted to draw a Lewis dot structure of fluorine, we would draw an F and we would put 7 valence electrons around it, just like this. Okay, so this is important to know as we get ready to draw these Lewis dot structures for covalent compounds. Now, we're going to start small. We're going to draw covalent compounds with single bonds. What single bonds means is that they share 1 pair of electrons and only 1 pair of electrons. So let's think about this. Oh, before we get into this, I want to talk about something called the honk rule. This is going to help us figure out how many bonds certain elements can make. So honk is an acronym. Okay, we're going to look at the first letter. H stands for hydrogen, but not just hydrogen, it also stands for halogens. And what I want you to remember is that hydrogen and the halogens can only form 1 bond. O stands for oxygen, and oxygen can only form 2 bonds. N stands for nitrogen, and actually not just nitrogen, but everything in the same group, so everything in group 15 can form 3 bonds. Alright, the same thing when I talk about oxygen. I'm not just meaning oxygen, I'm talking about oxygen and sulfur and selenium, everything in group 16. And then finally carbon and anything else in group 14, okay, carbon, silicon, and then on down, can form 4 bonds. And this is what it wants to do to be stable. Okay, so hydrogen, halogens, 1 bond, oxygen 2, nitrogen 3, carbon and anything in that group 4. Okay, so when we draw Lewis dot structures, what we want to do is we want to remember, we're going to go back a minute, covalent compounds. Let's think about this. We're talking about only covalent compounds. And what I want you to remember about covalent compounds is that they're formed only between nonmetals, okay? And we said that when we form covalent compounds, we're talking about atoms sharing electrons. So these pictures we're going to draw are going to show that the atoms are sharing their electrons. Okay, when we draw the Lewis dot structure, there's a couple of rules. Okay, typically the first element in the formula is a central atom. What that means is when we draw the compound, the element that's listed first is going to go in the middle. So for example, if we were drawing CCl4, carbon is first, so we'd put carbon in the middle and then we'd put the other things around it. The only exception to this is that hydrogen can never go in the middle. Okay? And this is because it can only make 1 bond. Okay? So let's just kind of get straight into this and see what we're talking about when we're talking about drawing Lewis structures. Okay, let's do an example. CCl4. Okay, the first thing you want to do is you want to take that first element and you want to put it in the middle of your atom, of your molecule. And then you're going to draw the other parts around the outside. So I've got 4 chlorines, I'm going to put them around the outside. Then we want to draw in the valence electrons. So we look at our periodic table. Carbon is in group 14. That tells us it has 4 valence electrons. 1, 2, 3, 4. Okay. Now we need to look at the chlorine. Chlorine is in group 17. That means it's got 7 valence electrons. So I'm going to draw 7 valence electrons around my chlorines. Oops. All right. Okay. So with just my Lewis dot structures of my elements, it looks like this. So I forgot this chlorine up here. All right, now what's going to happen is when we have covalent compounds, remember every element wants 8 valence electrons. In covalent compounds, the atoms can't give away their electrons, or they can't take them from another atom. What they're going to do is they're actually going to share the electrons between 2 atoms. Okay, so for example, if I draw a loop, what I'm doing is I'm looping these electrons. So if I were to redraw this compound, it would look like this. If I were to draw it where I have lines, where I have loops, I'm going to make lines. I'm going to draw bonds. Okay, everywhere that I've made a loop, I'm going to draw a dash, and what that dash represents is a bond, a single bond. And what I mean when I say a single bond is it's 2 electrons, or a pair of electrons, that are being shared between those 2 atoms. Okay, so this bond, this line is 2 electrons. So now think about it. Every atom wants 8 valence electrons, right? So if you look, you can see that this chlorine, if it counts those 2 electrons in that bond, you can see it's got 2, 4, 6, 8 valence electrons. This chlorine, if you look at it, 2, 4, 6, 8 valence electrons. This chlorine, 2, 4, 6, 8 valence electrons. So all of these chlorine atoms are happy, 2, 4, 6, 8 valence electrons. What about the carbon? The carbon has, if you count each bond, 2, 4, 6, 8 valence electrons. So our Lewis dot structure of CCl4 looks like, and I'm just going to do this real small, whoops, again, like this. And then we have to draw our extra lone pairs, or what we call them, of electrons that are not involved in a bond. So each atom has 8 valence electrons. Let's look at another example. NH3, okay? Remember we said that the first atom listed is going to be the central atom. So we're going to draw nitrogen. And then we only have 3 hydrogens, so we're just going to draw 3 hydrogens around, one on each side of the nitrogen. Okay, until we've drawn all 3 of our hydrogens. Now if we look at nitrogen, nitrogen has 5 valence electrons. It's in group 15, so let's draw that. 1, 2, 3, 4, 5. Hydrogen is in group 1. It only has 1 valence electron. And remember, hydrogen's a little unique. Hydrogen only wants 2 valence electrons to fill its first shell. Okay, so hydrogen's the only element on the periodic table that when we draw Lewis structures, we won't want 8 electrons around. Now, if we do the same thing, we go through and we draw bonds wherever there's a single electron. Okay, so here's a single electron on nitrogen, a single electron on hydrogen. We're going to loop them together, and essentially that's showing where the bond is. Okay, so now if we draw this, if we draw a line everywhere that we have looped 2 electrons together, it's it's going to look like this. Don't forget these 2 electrons up on top of the nitrogen. Okay, these are called lone pair electrons because they're by themselves. They're just on the nitrogen. They're not involved in a bond. But if you look at this, now nitrogen has 2, 4, 6, 8 valence electrons, and each hydrogen has 2, so it's stable, it's happy. And remember our honk rule? We said hydrogen can make 1 bond, nitrogen's in the 3rd spot, nitrogen can make 3 bonds. Okay, so we're kind of following that honk rule. Let's do one more example. H2O, water. Now remember we said hydrogen cannot be the central atom. Okay, so in this case, we're going to put oxygen in the middle, and we're going to put 2 hydrogens, 1 on each side. Okay, now think about our honk rule. The honk rule said hydrogen can make 1 bond. How many bonds can oxygen make? 2. Let's see if that follows in when we draw our Lewis dot structure. Oxygen is in group 16, so we have 1, 2, 3, 4, 5, 6 valence electrons. Hydrogen has 1 valence electron. So now we're going to start looping our lone electrons. Okay, there's a single electron here, and there's a single electron here. So if I go and I draw this out and I put in loops where I have, or I put in bonds where I have loops, if you notice, I end up with 2 lone pairs of electrons, 1, 2, and 2 bonded pair of electrons, okay, in my water molecule. So this is what we're going to do when we draw Lewis dot structures. We will practice more in class, but hopefully this gives you a little bit of a preview. I will see you soon.